So welcome back to another video, and in this video we're going to cover Alan's new Dakin air source heat pump. It's going to tell us how it works, how long they take to install, and tell us is it suitable for your home.
First of all, I'd like to thank Viva Training who have supplied this air source heat pump for us so that I can test it at my property and just to see the benefits of it and see if it is better or worse than having a gas boiler.
So how does this unit work? Obviously there's bits inside, there's bits outside. We'll cover the bits inside in a moment, but this unit here, how does this produce heat?
So in a basic form, it takes heat from outside. So at whatever temperature it is, it goes through the heat pump. So you need a space behind there, you need quite a lot of space.
To get air through.
It sucks the air in.
Yeah. And
then it brings colder air out here. It transforms in that magical device.
Yeah.
And it goes in the house as hot water.
And how efficient is this unit out here?
It could be up to 400%, maybe more percent efficient in warmer weather.
So for
colder weather, obviously it's going to be lower.
Yeah. And what temperature can this unit get to?
About 60 degrees.
Right. Okay. Cool. And in terms of installing them, you obviously need some space. Obviously, you're lucky. You've got a garage. You've got plenty of space down here. Do you need space behind it, space to the side of it, space in front of it?
Yes. So you need 300mm behind it.
Yeah.
To allow the air in.
This one's on a frame, isn't it?
You need space under as well. You also need some good form of drainage, because what we found from this is it produces a lot of water.
Right.
So if you didn't have that, then obviously the floor could freeze.
Yeah.
So obviously we've got gravel here at the minute, so it's okay for us. And then you've just got your flow and returns there that go into the flow goes in, goes round the buffer, and then back out and back into your SRC pump.
And if your tank wasn't in your garage, it was upstairs in an airing cupboard, those pipes would run up the wall. In
a lot of cases you do see them where they run up outside wall, and personally I wouldn't want that like that
no.
at my house, but
okay.
That's just, yeah.
Cool, fantastic. Let's go and take a look inside, learn a bit more about how these units work. Okay, so we've looked at the outside unit, and obviously Alan's explained how that works, what it does, where you need to site them, and some of the complications and benefits of having a heat pump. But to have a heat pump, you also need other equipment. So if you've got a combi boiler, you'll just have a boiler on the wall, and that boiler will do heating and hot water. With a heat pump, you need to have a cylinder. Now, some people will have cylinders existing because they've got a boiler with a tank, but you would need to change that tank to something like this, wouldn't you, as part of the kit?
Yeah, well, that would be a better. You can put an hybrid system in where you can use a combi boiler.
Yes, we're going to cover those. So yeah. There is a product, or there's products coming to the market. One of them is made by Alpha. We saw that in Italy when we went across there. They produce a combi boiler and an air source heat pump, and that'll do your heating and your hot water without the need for a tank. There's going to be some content coming on that shortly. There's a lot of noise outside, sorry today, because I think there's someone knocking something down. So just talk people through what this does. Obviously the unit outside we've talked around, that drags in air, converts that air through reverse refrigeration, creates heat. What would this do, and why would you need one?
So what we've got in here, so them pipes that we talked about outside, we've got your two pipes that come in here.
So flow and return.
Flow and return from the heat pump.
Yeah.
That goes then to this diverter here. One side of it goes to the hot water for your hot water, and then one side of it goes down to a buffer. So this has got a built-in buffer.
Because some units you need a separate buffer, don't you, to defrost the air source heat pump.
So this makes it easier for installing, if you like, as well, because it's got a buffer. You've just come. This is a pre-assembled cylinder as well.
Right.
So it has all this stuff on it already, and you just connect onto pipes, and then that goes into buffer, and then comes back out at buffer. Well, it actually goes over where that's the return. So these pipes here are your main heating pipes for your central heating, and then that one there is the return there, back into the buffer.
So what does the buffer do? Obviously, so if this was two separate units, why would you have a tank and why would you have a buffer?
So that you've got more water volume. So,
right.
So a combi boiler will modulate down.
Yeah.
With an air source heat pump, ideally you want to keep it on all the time, but at a lower temperature.
Yeah.
So for instance, if you started shutting valves off and TRVs and stuff like that, you'd get
they're going on and off,
You don't want to do that, so the buffer puts more volume into the system.
Right.
And also, in cold weather, that buffer will defrost outside, so it keeps it warm, it don't freeze up, and
right. Okay.
so you need the volume of water.
So, top half of this is doing the hot water.
Yes.
Bottom half is a buffer. This is one type of system. There's other types of systems where you'd have a separate buffer, separate tank. How do we deal with, obviously, the units on at the moment, we were just discussing then, good for children because you never burn your hands on it. The water, doesn't feel hot, it's 35 degrees. What temperature could that get up to? And because domestic hot water is normally about 60 degrees, isn't it?
Yeah.
But the efficiency would drop right down if you turned a heat pump to be set at 60 degrees. So does this use a combination of the immersion and the heat pump to get you to 60?
So this heat pump will go up to 60 degrees.
Right.
That will lower your efficiency by doing that. So you might get, I don't know, you might get 2 to 1, you might get 2.5 to 1 or whatever.
So when we talk about the ratios, like 2.5, 2 to 1, what that means is for every percent of fuel that goes, or every unit of fuel that goes in to electric in this case, the efficiency on a heat pump is generally targeted around 400% or 4 to 1. So that means every pound you put in, you get effectively £4 worth of heat out the unit. As you turn the temperature up on an air source heat pump, that efficiency ratio drops, doesn't it? So when you're 2 to 1, that means every pound you're getting £2 worth of heat out the unit. One of the challenges with an air source heat pump, you know, just being critical,
cost of electricity
is about 4 times higher than gas, isn't it?
Yeah, so for me, we pay 40 pence for per kilowatt hour for electricity. We pay 10 pence on an overnight charge, but we pay 10 pence for gas.
Yeah.
So through the day, if we had no other technologies, then it would be challenging, to say the least, to get it to perform
at the right
same level as gas
for payback
on pricing.
Because if you're 40p a kilowatt and you get an efficiency of 4 to 1, that's 10p a kilowatt essentially, isn't it?
Yeah.
Now, if you are on gas is about 12 pence per kilowatt. Between 8 and 12 pence.
I think I pay 10 pence.
10 pence.
It would be very similar.
So it's similar. The benefit here is if gas moves, it starts to make financial sense.
Yes.
Or if electricity comes down,
yes,
it makes financial sense.
Yeah.
And if gas doesn't come down at the same time. And as a standalone unit, there's obviously I'm guessing these aren't cheap. This was donated to you, wasn't it, by Viva Training?
Viva Training supplied this for us so we can. I did have an air source heat pump. We've took that one out. We've put this one in.
Yeah.
We're just doing some tests, see how efficient it is. The one thing to point out with this is, if it's on for a long time, it starts to become more efficient. So, for instance, yesterday I had this on. It wasn't a freezing day, but it was a coldish day, and the floor temperature was 37 degrees. And the house was steady 21 degrees.
Yeah.
Because I've got thermostats in every room, so that I can measure it all.
Yeah.
And the house, it were working quite well at them temperatures, but that's having it on a long time. So the thing with an air source heat pump is to get the correct SCOP, whatever you want to call it.
COP is the 1 to 4 ratio thing, isn't it?
Yeah, SCOP is seasonal, so that's like. If you're going to do it over a short time, so like we just measured it over summer, then obviously you're going to get better results from that. Yeah. So that wouldn't be a fair test.
No.
So that would be
you do it over a full
So you do
season.
it over the full season.
Yeah.
So in summer, obviously, because the outside air is warmer, it's going to be a lot more efficient. In winter, obviously when you need it the most, it's going to be less efficient.
Yeah.
So then it's just balancing that out to see if that then stacks up.
See if it adds up. Yeah.
But it definitely worked for this house. There is downsides, I would say. One of the downsides is if you open up a door and you're letting cold air in, so in an hallway or whatever, then it's not as reactive to get back up to temperature.
Yeah.
So we've got one of our rooms is like a sunroom. It's like a little bit like a conservatory, but it's half a conservatory, and that room, the temperature is high and low, so if it's sunny outside it's too warm, and if it's cold outside it's too cold. Well, that's a tricky room to struggle to manage, to manage that. But overall, it works really well. But you do have to have it on for a long time.
And there's other commitments, isn't there? So your air source heat pump, that's a unit outside. So you obviously we discussed about the space you need and the size and the sort of look of the unit. If you haven't got a tank in now, you have to have a tank put in. If you've got an existing tank, you've got to change your tank for something that's suitable to work with an air source heat pump. And then there's a third dimension, which is the radiators. So if the flow temperature, obviously it's 35 degrees now, through a standard size radiator, when radiators are sized up for most properties, they're sized up for a flow temperature of sort of, was it 80 degrees?
About 70-ish, isn't it? Yeah.
70 degrees. If it was 70, 35, you now need twice the surface area to get the same effect. So you'd be looking at a unit, a tank, a buffer, or in this case it's built in, and radiators. Or you could have the heat pump working harder at 65 degrees to get near that 70 degree flow temp, but the efficiency rating will drop down from 4 to 2, which makes it twice as expensive as gas. And this is the balance, is, you know, just looking at it sort of from the outside looking in, the deals make sense, or the capital investment makes sense if the energy market moves. Like if gas moves up considerably, these start to become financially viable on a payback. If it stays where it is, you're about net in the same position to run without some other stuff, but you've got the capital investment of the unit, the tank, and the radiators. And also, just one other thing to consider is pipe work. That's 15mm, that's 22mm. You generally need 22mm as your circs, don't you, or 28mm?
28, so we've got 28.
And 22 to your rads.
That's for D2.
Yeah. So there's some pipe work upgrades to go. So now obviously it's a lot cleaner because you're not emitting emissions here at the property. They may be getting emitted elsewhere, but they're not getting emitted here because you've not got a gas boiler. But it's a significant investment, and this is one of the challenge from a social perspective, which is, you know, from a budget, and does this technology, is it exclusive to a certain proportion of the population?
With regards to the radiators, sometimes you will need to update the radiators.
Yeah.
Sometimes you might get away with some of them. Sometimes we're oversized. So when we've had loft insulation and we've had windows done, then the radiators in the room are oversized.
Anyway.
They are oversized. But normally, you're right, that for me to get this house working really well with really low flow temperatures, the bigger the radiators, the better really, but balanced so that every radiator in every room is the same amount bigger, if that makes sense?
Yeah.
So that when you're putting the temperature in, so if I'm putting 37 degrees round as a flow temperature, instead of what I might have in the past put 70, then I want all the radiators correctly sized. So it's a much more, what would I put it? You've got to be a much more experienced engineer than just putting a combi boiler in and it'll just work because the temperature's so high you can get away with it.
That's it, there's lots of training that needs to get done. Obviously, we mentioned in a previous video, we're actually launching some training programs for our existing engineers about upskilling into renewable technologies. You're having some experience with these technologies. Obviously, you're super keen on reg, standards, quality, which is why we first got involved together, and we're going to be working together on those days. So there is lots of upskilling to do. There are other solutions out there as well that we could quickly touch on. You know, we'll do a full separate video for this, but for example, there are hybrid solutions. So we mentioned earlier Alpha, which we've done some videos going over to their factories in Italy. Massive company, loads of R&D. They've just launched a product in the UK, which is a gas combi boiler. So you're paying 10p a kilowatt for your gas to be produced out of that unit today, 2023, depending what tariff you're on. And you then have a small air source heat pump. Still has the efficiency of 400% or 1 to 4. That sits on the system, but it's only 4 kilowatt.
So so in the summer or in the not so cold times,
that's
the air source heat pump it'll be amazing.
Yeah.
And it will definitely be cheaper in most cases to run an air source heat pump.
You don't need a cylinder.
You don't need
You don't need to change your radiators because it can run at a higher flow temperature. Now, the reason it can run at a higher flow temperature is the air source heat pump's only going to be set to sort of 45 or 40 degrees, but the boiler can do the topping up. So like you said, in milder months, but when there's still a requirement for heating to be on, the air source heat pump will be working away. And then in the cooler months, when the air source heat pump, if it was turned up to heat that house, the efficiency would drop through the floor, the gas boiler will kick in and do the heavy lifting, and a gas boiler will also do the hot water. Now we're going to go and see one. Obviously we're actually installing one tomorrow in a property, and we'll be doing some filming on that as well. Alpha claim that it's around 60% reduction in the gas demand for a property.
And there may be some sort of technology that can be used as well to manage that, so that it chooses the best tariff.
It does.
So does it do that already?
There's a controller that sits in the middle. You enter your kilowatt pence per kilowatt charges into the controller, and the controller will make a decision based on the outside temperature sensors which is the best system to use. So it might be the gas boiler, it might be the air source heat pump, it might be a combination of both. The other benefit as well, which we haven't touched on but is relevant to solar, is the unit's only 4 kilowatt. So because everyone's moving, not everyone, a proportion of people are moving to electric cars, people are looking at air source heat pumps, people are generally putting electric appliances, there's more electrical demand per property now. The grid can only supply so much electric, and there's something called a DNO, which is your district network operator. If you exceed an appliance of, I think it's 3.9 kilowatt or 3.7 kilowatt, you have to have an application go in. So your air source heat pump outside was,
I think that's 8 kilowatts.
8 kilowatt. So you couldn't install that without permission off the grid to say, yes, we can supply you 8 kilowatts. And if they declined it, you can't have that product. They may even charge you to upgrade the substation to allow you to have 8 kilowatts. With this Alpha system, the unit's rated at 4 kilowatt, but it actually can work on a 3-pin plug, which is 3.7
Really?
kilowatt.
Wow.
Yeah. So you don't need a DNO application, you can't be refused, and you know, what we've got to be mindful here is as more and more people move to these technologies like air source heat pumps, electric cars, there may be throttling on the grid that sort of limits your amount you can pull or send back to the grid. Same with solar. We've got sort of 3 or 4 solar installations out there now on test. Anything under 3.7 kilowatts, it's not a problem. You can put it on your roof. You don't even need to request any sort of permission. Above 3.7 kilowatts, you need to ask the grid, can we export more than 3.7 kilowatts? And they'll give you a yes or a no. And interestingly, on some of the jobs we've done, same street, one got accepted, one got declined.
Did they tell you reason?
No. You can appeal it and find out, but it's just someone hitting numbers and buttons. It depends on the existing load on that street. Just because they said yes to that person, since then 3 or more people are now pulling more. With the advent of smart meters, they know what's going into people's properties. So that's another benefit of the Alpha system. There is another alternative to an air source heat pump, a low temperature one, which is a high temperature one. So Viessmann do a high temp unit, and I think it still works.
Daikin do as well, so they do. So I could have had a low temp or a high temp here.
Yeah.
I actually chose the low temp because of how I wanted to run it.
Yeah.
But you can have a high temp as well, and that does go up to, I think it's 70 degrees.
Yeah, and the efficiency is still strong on them.
Yeah.
The only challenge, like everything was positive, you know, there's always a negative, the cost. So Viessmann do one, it's a great bit of kit. When it's up at 70 degrees, it's not as efficient, it's not far off, but the cost is still an issue. And you still got to have the tank, you still got to have the buffer. You also need a defrost unit with some of the units as well, because the way they work, they can freeze up outside. So the system uses energy produced to defrost the unit. With the Alpha system, interestingly, the gas boiler just fires momentarily.
Some systems as well also need to have antifreeze in.
Yeah, glycol stuff is it?
Yeah, glycol, yeah. Mine, we've got anti-frost valves on this one, so we haven't, but some systems do. some manufacturers request that.
Yeah.
So that's another thing to
Consider.
put into the mix, because that's very expensive if you're going to bleed your radiators. And
Yeah, I mean, if you had,
future.
if you've got the money, you've got the space for the cylinder, you've got the space for the unit outside, it makes sense. Where it can also make sense is combining it with another renewable technology. So obviously the reason we're looking at solar and we're launching solar is it helps reduce the demand on people to buy from the grid, but it can also power stuff like air source heat pumps in summer. You can charge batteries, you can use those batteries on a low rate charge at night. So if you take Alan's air source heat pump on a 1 to 4 efficiency and you say electric's 40p in the day, if you can charge batteries at night at 10p, he's going to run his air source heat pump for 2.5p in relative terms.
That's exactly what I'm trying to achieve. In the summer, when we are getting that at 400%, we'll be using the sun. So the solar panels will charge the batteries, and they'll run the air source heat pump through the day, and then we might even send a little bit back to grid. And then on a night, if we need to, we can top it up on cheaper energy. We can pay 10p per kilowatt hour, and we can charge the batteries back up. So it depends. So in the winter, the batteries are not quite big enough at the minute to fully run the air source heat pump through the day. So if we have the air source heat pump on through the day, we would be paying 40 pence per kilowatt, which would be quite expensive to run the heat pump. But we are getting extra batteries. I've actually got a box there with a battery in. So then we'll have enough batteries then to charge them overnight at low rate, so at 10 pence per kilowatt hour at the moment at current rates, and then we can run the air source heat pump through the day on that cheap rate. So for us then, it works out cheaper than gas. To be fair, that's a massive investment. So if we paid for all this stuff that we've got here, once we've got us 4 batteries there and solar panels, there's probably £40,000 worth of renewable technology there to be able to save a little bit on us bills.
That's the challenge, isn't it? So you're paying £40,000 to get back to the equivalent gas unit now of 10p. Now if gas becomes 50p, people are going to think about this differently. This is, people might say we're negative about air source heat pumps because we sell gas boilers. We're a business, we would sell products that make the most commercial sense, that also are, that meet the demands or the, sorry, I've got there, 2 secs. What was I saying then? You have to cut that bit out at the end. What was I going to say then?
Negative as a business.
Yeah, okay, yeah. So people may criticise us for, people might consider that obviously we're going to be quite pro gas boilers because that's what we sell. So we're a business, so we'll sell products that make commercial sense. We've also got an environmental strategy behind the business, so it's not all just about the best commercial gain, it's about the most practical solutions, the most affordable solutions for customers, and what's going to help us get to net zero. We've got to consider all these technologies. For me, pound for pound for a replacement, a gas boiler is still the most economical way to get your heating back on, to save money. If you've got an old inefficient boiler at 65%, 50%, you change it for a 90% efficient product, you are going to make a saving. That's a separate issue than dealing with net zero.
Even if the air source heat pump was, let's say it were 10, 15, 20% cheaper to run than a gas boiler, then the overall cost, if you say a life of a boiler, if you were an accountant and you wrote it all down, and it's cost you 15 grand, say, or in my case 40 grand, and then you work out the cost compared to just having a combi gas boiler up wall, then you've got your gas bills for the next probably 30 years with a combi boiler. And
the bit that we've got to deal with there is there's the environmental impact of gas boilers, but there's also the social impact of technology like this, which it does exclude a large proportion of the population who can't afford it. There's also as well, which is a whole other rabbit hole, this is using electricity, if you didn't have solar, to power the air source heat pump, but we burn about 60%, our electricity comes, 6% of our electricity comes from burning gas. So whilst there's no emissions being emitted out of that unit on this site, those emissions are offset elsewhere. It's like when big companies buy trees and say that we're not producing any carbon because we plant trees. it's not quite as.
But I think a lot of people that go down this technology will buy from the grid, will buy from suppliers that give green energy.
Yeah.
So they will actually, in one sense, they will be paying slightly more for their energy because they've got other agendas, if you like.
That's the piece.
So for me, I get mine from Octopus, which is, they try and use green energy.
Yeah, which is good again, but there's a cost to that, isn't there?
Yeah.
And that's the bit that comes back to the social piece, which is, we're excluding people from this technology who may want to go green purely because of cost. So I think there's lots of things to think about, how we can make that more accessible for people. And also there's other products, the hybrid solution. For when I think about cars, I haven't gone full EV, but I have a hybrid vehicle. So I drive to work and back on electric, and then when I'm on longer journeys, I use the engine. And one of it is cost, obviously. Investing in a full EV is expensive. Second is the infrastructure. And third is, I want to do my bit, but I've got to be realistic. So these hybrid solutions for cars can also be akin to hybrid solutions for heating. So that alpha system where you've got a small air source heat pump, like on a hybrid car, you have a small battery, and then you've got an engine, like a hybrid car, doing the heavy lifting. It's a transition. If you can cut your gas dependency by 60% with that product at a price point which is probably 4 times less than an air source heat pump, and you've not got to disturb the property, because if you change pipework in walls, you've either got to have that surface or you've got to chase that out, replaster and redecorate.
Well, we've changed a lot of, I've updated our pipework as well, so I've put 28mm pipe in.
Yeah,
which
it's a massive investment, that.
We bought this house to do quite a lot of work on it anyway, so we were going to do all that stuff. But if you're going to go into I think there's different solutions for different people, and depends what you're going to spend as well.
Everyone's got a choice, and it comes down to that. There is no one prime solution now where you go, right, that makes total sense, go for that. It's very much applicable to the property, the affordability. Does the network support it, as in the electrical, in the grid, can they support it? And also, personal preference. I want to buy green energy and I want to invest in this technology. It's not going to save me any money, but for my own peace of mind, I'm doing my bit for the environment. Then there's a greater challenge, which is, okay, the energy that's powering this, where's that coming from? You've done things about that because you've got solar, you've got batteries. But if you're buying off the grid,
it's turned into like a little bit of an addiction, really, because you start with one bit and then you oh well, if I do this, if I do this, and then it's, as I say, if you added all that up, it's a lot of money.
It's a lot of money.
We've been lucky that some of this stuff we've had donated, to help us, see what we think to it.
But it's great this though, because this is like a typical housing stock, isn't it, of the UK, or certainly represents a large proportion of the housing stock. So for you to have all these different technologies and to be doing this content, it's great. So this content is free to consume on YouTube, free to watch, and people can do research. You've not got to commit, it's straight out of the box.
The thing as well is, with my stuff is, I'll just tell the truth.
Yeah.
And with what you do, even when you get bad reviews and stuff, you don't delete it.
Yeah.
You take it head on. We've done something wrong. Let's.
You want to know exactly, and that's because people need to make their own mind. Because there's not one sole solution there now. You've got to consider all these different variables, and I think there's lots of noise about air source heat pumps. Obviously, the government's running the buzz scheme, so you can get £5,000 towards an air source heat pump. Apparently, it's getting cancelled, but there is funding options out there. However, I think what's going to be really interesting content moving forward is that hybrid going in, looking at it. We'll go down to Alpha, take a look at one, see how they work, meet the experts at Alpha, they can give us some more information, and that might be a viable option which may become affordable for another proportion of the population, does reduce gas dependency, and hasn't got the headaches of this. Although this is a brilliant system, there are challenges. So good video, enjoyed that. Obviously it's good to come down, see the system, see what's going on, how it works. The last time we saw you had a different one, you've now got this one. This is better, more positive. We'll do some more content on the long-term cost of it, maintenance, you know, how it's fared in summer, how it's fared in winter, and we'll constantly update these videos. So I really appreciate that. We appreciate everyone's time. And yeah.
If you've got any questions as well, put them below and we'll try and answer them.
I'll answer them. Yeah, you know what you're saying.
I'll try and answer them. I'll look on and try and answer them.
We'll try and flog your boiler. Cheers.